Good morning.
Good morning.
Morning.
Morning. Yeah, how is everyone today?
Pretty good. How are you guys?
Pretty good? Doing well? Yeah, so it's good. Welcome back, Amanda. I know you've been gone for a while.
Yeah, thank you.
Yeah. So, yeah, we have a slight thing about the Jitsi room that you have to log in now to be, you have to be authenticated to enter in if you're the first person in. If you encountered that, I just wanted you to be aware that that's a thing that they're doing, at least on this server. It's just to prevent malicious actors from doing things, and you just use your Google or GitHub account. So, just a heads up on that. All right. Any updates or things people want to talk about before we start the meeting?
I don't think so.
All right.
No, I guess just updates for after we start the meeting.
Okay, yeah. All right, so let's get started. So we're heading towards the fall. We're leaving summer behind. We're still continuing GSOC though. We're continuing that until late October because we got extensions. So that's good. And so we'll continue to update on that. I don't know if we have anything in terms of like internships coming up, or have we moved anything on that? I haven't really done anything on that.
I have to look into it a bit more because the U Albany stuff that we've done before, there's been a restructuring on their end about what they're doing. I'm not sure it's going to be the same this time around, but I might try to look a bit at that now.
Yeah. So
they've restructured their whole I don't know how to say it. The programs where they house the things. So we'll see.
Right. Yeah, I know what you mean. It's the program that they have for where they administer it from. So.
Yeah.
Okay. Yeah. Well, we'll keep on that. I guess it's always a challenge. I know they've done that in a number of things that we've been working with. They're always restructuring things, so rules are always changing. But we'll work on that. Again, there's no deadline. It's just we, would like to take opportunities where they arise and use them. So yeah, we've been working on. We're back online with respect to cognition futures. We're working on papers. We have some papers that are due, I think in November. Is that when you're
sometime in November.
Okay, yeah. And that's the Philosophy of Mind conference. So that's
if you want to look at the the chart, I can show the timeline thing. Where is it?
Yeah. Okay, yeah, that's good. We can do that. So yeah, this is we haven't looked at this in a while. This is the all of our submissions that are currently active. So we have the top GSOC 2023 that's happening now, so it's continuing to happen. And I think we marked off where it kind of ends. Well, I don't know if we marked off to where it actually ends. It actually is supposed to end October 23rd. I don't know if it's at that point.
Okay. So it goes. I'm going to zoom in a little bit here. A little bit more expanded view, but yeah. Okay. Yeah, there's also We Robot, which probably should be extended a bit more.
Yeah. When is this coming up?
Next month.
Okay. So you're planning to go in person for that, and that's going to be kind of like last time.
Down the road for me, so.
Okay, good.
I forget what it is actually. Let me look.
So yeah, I guess we're in hand with the poster. I guess there are posters for that, or.
Yep. I'm gonna do one on Frontier Map and one for Plot Twisters, basically.
All right.
So
I remember the Frontier Map one, yeah. And so that'll be interesting. That sounds good. So then we have the first annual web conference for the Society of Mind, Philosophy of the Sciences of Mind.
The event for this one is what's the date on it?
Got to change it to accepted.
Oh yeah.
Oh, looks like there's two different dates. It's Friday and Saturday of November, and then like November 25th, and then Friday and Saturday of December 25th, or Friday and Saturday of December 1st and 2nd. So it's like 2 weekends back to back.
Oh, so it's discontinuous.
Yeah, there's a discontinuous break.
Interesting.
I guess, yeah, if it's a web conference, you can do that.
Yeah. I've never even thought about doing it like that. Because usually you want to keep people together for a block, but you can see why it would be good to not do that.
Right, that way you can avoid weekdays, so maybe more people can join.
Yeah. Also, people get burnt out after about 2 days.
Yeah. Yeah, so the last Cognition Futures meeting, we spent most of our time talking about a paper that was recommended by the reviewer comment for my submission to this. And the paper was on cardiophenomenology, and it was very relevant and very interesting, and we're continuing with the conversation at the next meeting. I also do think that microphenomenology, another thing recommended by the reviewer, is worth looking into. So I will find a paper that I think is good for that. I think it's, even if the concept itself isn't the most exciting, I want to find a paper on it that also explains like basic phenomenology well, in the context of Varela's project.
Right. Yeah, I'd be interested to see like what they mean by microphenomenology and how it kind of relates to some of the other things we're doing in the lab, especially some of the agent stuff, because the agent stuff you're trying to simulate like the sort of, how behaviors are generated in an agent. And, you could use a neural network, say, and you're generating behaviors. And then the question always is, how do you generate a behavior? Is it a simple process, or how does it unfold over time? So, like, for like a Bradenberg vehicle, Valentino Bradenberg proposed that there were these little, you would have like a artificial wiring scheme, and that you could wire it in different ways, and it would produce these very basic behaviors. And then he tried to attach emotions to it. And so this is like, a very basic level behavior. But if you want to go beyond that, if you want to change the network over time, if you want dynamical behavior, then it's a matter of like mapping the patterns of that to some behavior that's stable. So it's like you have a micro phenomenon of like the network state at any one time or a bunch of different times, and then that sort of translates to that behavior. We don't, of course, we don't know, because that's kind of like the problem of random behavior. We don't really know how that all gets generated. And, that would be very useful to say, we can look back and see, how that mapping occurs and what the sort of the rules of that mapping are. So I think it'd be very useful. We also mentioned the timeline, or the time scales. So we have, the micro time scale and the, I guess, non-micro time scale of milliseconds, time scale of, say, minutes. And how do you map, say, like neural activity at like microsecond timescales, but sort of going over 15 minutes versus a behavior that unfolds over 15 minutes. And then that's a problem of mapping, but that's also a problem of this circuit just kind of going over and over and over again. And if it's, it's not obviously not spitting out the same output all the time. It's changing its dynamics. So that's a really interesting area. To me, anyways.
Yeah, my impression of microphenomenology is that it's supposed to be like phenomenal reduction, but on this shorter time scale, it's supposed to give like more fine-grained, first personal results. But I'm curious because my understanding of phenomenal like reduction was that it was like encompassing whatever time scale you're looking into. So my open question is like, is microphenomenology just like arguing for a particular shorter time scale at which to practice this, introspection, or is it something? Is there more going on?
Right, that sounds good.
Yeah, I'm quite curious about that myself because I feel like I really want to get to become very versed in this particular matter. I'm going to try to share this. It's not complete, but I started putting together something along these lines because I feel like I want to familiarize myself with this, but also I guess I'll just do this. Here we go. There's different things. I know we talked about it. There was discussion. There was this line about naturalization of phenomenology and phenomenology of nature, and there was discussion about that's like 1p 3p to 3p 1p and the informal constraints and these different things about these different things about the generative and operationally generative nature of the constraints. And I feel like and I didn't finish this yet, but I'm kind of just want to frame this as well as it can be, and get at what this is sort of doing here, because there's I think it's a key thing to go at. I can zoom in a bit here, but from Varela's and that sort of, here's the word again, right? That isomorphic idea, and we've talked quite a bit in this lab at the meetings about isomorphic and the different ways that isomorphic is used and gestured towards and implied and actually explicitly used here. And I'm not really going to try to make a comment on what version of that this is, but we can discuss that if we want. But I feel like there's I think this is a really interesting line related to the broader sense of things, in that and this is from the article we read last week, the card phenomenology by Dupraz and DeSmit. But just this bit about excuse me, where did it go? The paradigm of naturalization of phenomenology is more accurately identified against the narrow understanding in terms of reductionist empiricism as a phenomenalization of nature. In this case, not be understood in empiricist phenomenology, devoid of its phenomenalized transcendent dimensions. And I guess why it keeps standing out to me is there's something that came up in the meeting that I'm not going to like pull up some of the quotes from the meeting about it, but there's something that came in the meeting that I gestured towards something like, oh, phenomenology of everything. And I think it's more accurately captured by this. And I need to figure out how much my understanding of what this is getting at, and kind of the rest of the this is like kind of the next few paragraphs from the paper. But I really like the description of the difficulty in concretely and effectively applying the generative constraints. Yeah, and this is where the timescale decision came up from that Bradley just mentioned. So I think both of these things that we're talking about here, you know, these sort of specific takes on the cardio or other things. So we had quite a range of, I'll just put it like, what are the scales of I don't know how I want to say this. I'm not finding this quite right, but basically, what are the scales of what did Fuchs say? Basal effectivity. A question that leads me down this line is because in Fuchsian sense, basal effectivity is like the basic stuff, like the lowest form of things you can kind of be conscious of in one sense, or like the simplest, most foundational things that isn't quite, it's, I don't know if he used the word like, I don't think he used pre-conscious or pre-reflective, and there's a bunch of things that I'm reading and have read, and I forget, they're all meshing together in my mind right now about the pre, etc. stuff. But sort of what are the lines, what are the limits of things that as a conscious entity there's the basal effectivity, and maybe slightly above that in the Fuchsian sense. But where does the line between the basal effectivity come? These different sort of applications for the phenomenological giving us something we can actually sense internally and measure against internally, and the timescale deal about that. And I think part of the difficulty is about that. And I feel like I really want to try to understand the difficulty here as well as I can, because there's a lot of different components to it. And it's I mean, when I'm kind of over dramatizing it a little bit here, but also for myself, because I feel like there's a bunch of things here that I think are kind of being put together, and in the paper they're put together decently. Like I'm not really criticizing the paper, but I feel like to fully understand I think as I'm saying up here, like the whole this trajectory, like Verla's trajectory from unbecoming aware throughout, there's a kind of there's something there that I need to grasp a bit more. So that's partly why I started writing this immediately after the meeting and going from there. So,
Yeah, that's great.
That's great. I don't know if it wants.
So, are you working on a blog post on that? Yeah.
Yeah. Okay. Yeah. Well, yeah. Did someone join and go away?
It was Hussein. Yeah. I don't know. He might come in. Could you bring back the timeline for the submissions, if you could?
Yeah.
Great.
There's a few more things.
Yeah, there are a few more. One update.
I'm going to reshare this. Hold on. Go ahead.
Okay. Yeah, the BICA conference, I don't know if we have the deadline on that, but I have to work on a presentation for that. So the thing for the proceedings is been submitted. That's in process. We also have our in process for the EI workshop, which is for 2022. Oh, yeah. That was submitted. And, it's on its way to being published in the proceedings. It takes a while. I think last year it was published in like the fall. So we'll be getting notice soon that it's...
You're talking about last year's stuff right now, right?
Well, yeah, I'm talking about last year's stuff right now. Now, Jesse sent me an email, or forwarded me an email about this year, 2023. And that is, this is something that we can submit to. And the deadline for that is October 31st. So that is, and I think, yeah. So, so that's EI for 23. That's for the proceedings. And I know that Amanda may be interested in submitting something, and we might submit something else too. I don't think there's a limit to what you can submit, but I mean, the last couple of years, I've submitted things on behalf of the lab that were different from the talk that was given in the workshop. But it's nice if it tracks that, because it's kind of so it's an opportunity to get things in front of a wider audience.
And the 31st.
Yeah.
Which is
October. There we go. So that's coming up sooner, we'd like to think.
Yeah. It's gonna be a busy few months. I'm really bracing myself. I as much as possible, like today is gonna be a major battle planning day. I still, as a slight digression, I'm really trying to figure out I guess the easiest way to say it would be like a task management system that I like, that fits both the lab's needs and my own needs. And I have things like, I've been experimenting with the Motion, not Notion, but Motion. I've been experimenting, we have something just still in GitHub. We still have Notion itself, which is the main space, and I'm fine with it. I'm not going to change that. But within Notion, there's got to be there's some templates I'm toying around a little bit with, and I'm really trying to just group and block stuff, both like task selection, like the outlets, the outputs, writing, and the how to get the things happening in the blocks of time that I can set aside for them. And I know that's like the eternal challenge for all academic, scholarly people, grad students, or whatever else. Like, it's always that, but it's just, I feel a very, what I'm understanding here, and maybe we could talk about this later instead of derailing this part, but I really enjoy having a slight discussion on how can I write this down to remember? I'll put it in the Notion, I guess. Certain managing tasks. What I'm feeling right now is that managing tasks for closed. I don't want to say closed systems, but closed information. I don't want to say information perfect either, but like things that are more or less closed off in terms of the content and the theoretical scope of them. As opposed to tasks that are really pushing scopes or really pushing information in or out, like almost Von Neumann, or is it Von Forester's demons? Yeah. Von Forester's demons, like inside outside, like things where the demons are stable, feels totally different to me in terms of administration and putting yourself through it than things where they're not stable. And I think there's a lot of interesting, philosophical whatever about that. But just from the raw pragmatics of it, I'm realizing there are certain task spaces I'm trying to quote unquote optimize or whatever. But yeah, maybe we could talk about that later, because I could get into that quite a bit. But let's come back to that.
That's a great analogy.
Yeah.
Yeah, it's kind of. I was searching for something, and what came was like, oh, that. Yeah, isn't that weird? There's a few things in the Slack I wanted to mention too. A few other things that I found that are also just amazing. Let me see if I can pull them up for like putting on our timeline board.
Okay.
But I'm going to look for that for like a minute. Okay, I'm close to finding it again. Is there anything else you guys wanted to put on this list for now?
We have the learning on graphs, which was put on there because it was a kind of a long shot that didn't get submitted because we decided to do something else as a collaboration. But actually, that might be something worth putting on the board. This is from DevaWorm, which is there's a special issue of a journal that we're working on, and I don't know what the current title of the paper is because we've been collaborating on it and the title's changed a couple times, so I don't want to put it by title. But there's this. So if you take learning on graphs and you take it off, actually don't take it off. Yeah, DevaWorm collaborative paper collaboration. I think it's it's on a journal article. Yeah. So
I haven't been able to go recently, so I don't know which one it is.
Okay. It's actually a special issue on code biology. So that's the name of the special issue topic. Now this is being submitted by August 31st.
Oh. Okay.
And so that's like just a draft. They want a draft by then. And then I don't know how long it'll take to get accepted or rejected. Hopefully accepted. But yeah. So that's, it's good. And then the learning on graphs, I think, is just like, we might attend that. So we couldn't get a paper together for that, but that will be in the fall.
When's the actual event date?
Learning on graphs. I think it's in December.
Okay.
Like, we'll just put December 1 for now. Yeah. That's a fun conference. It's on Graph Neural Networks, and it has a lot of good stuff. Like, it's all virtual, so you can. They have these local meetups, so there are a lot of ways to engage with that. So we might do something with that too. I don't know. It just won't be a paper.
For last year's AI conference, Embodied Intelligence, would that be published, or is that we're still doing stuff with that?
Yeah, that would. I guess that would be published. It's not out yet, but it's going to be out soon. So one of the things we might do for that too is, we might prepare like a blog post or something on it, or I might do that, where it kind of talks about the conference and the proceedings. We have a proceedings from last year as well, so that could be included in the whatever blog post that comes out of that. So, yeah. And then the Gibsonian information preprint is actually shaping up to maybe be like a different paper altogether. No, it's actually going to be something like a primer on Gibsonian information. So it's going to be something different from like the paper we published in the Beaker proceedings.
So I have one thing to add to this list.
Okay.
I feel like I have a few, but I don't know. Okay. Yeah. Okay. I've got a few things. I can't go to this. I would love to go to this. I can't imagine just going, like, hanging out in December with Megan Peters and these other, like, conscious people.
Yeah, they're conscious.
Unconscious too,
Yeah.
Unconscious sometimes. In Mexico, that sounds like a great event. I'm not going to put that on our list, but if anybody knows somebody who wants to do that, that looks amazing. I do want to put this on the list: explanation in complexity in biology and psychology. I think that's what was the date? 22 through 23. Okay. Because that looks to be fun, and also, okay, can I get this here? Okay. I'm trying to find a good way. I'll just share my screen for this. There's something that we could submit to for other things, and it could be more of a plot twistery thing, but it could also be something we can do. It's a new journal. It's an HCI journal. Let's see right here. It's a new open science, which is cool for us. Open Journal of Human Computer Interaction. First issue in January. Call for research papers covering topics within the study of HCI. Publishing's free. I'm trying to figure out. This is kind of a confusing website layout for me. It gives you pros and cons. Oh, there's also one more too. Before I forget, I'm just going to write in Notion. But for this one, it lists the topics somewhere, and I can't remember where. Oh, here they are. Research. I feel like this should be front and center, but it's at the bottom of the page in a menu. But you have accessibility, adaptive interfaces, effective computing, augmentative alternative communication, augmented realities, BCI, cognitive computing, design methodologies, gamification, HCI, straight up, HRI, human robot interaction, speech, usability, and user experience. And I feel like we dabble in some of these areas, directly and indirectly. Gamification is very plot twist related, and there's a lot of, even though right now plot twist is not going to be like complicated in terms of, there's not going to be like a virtual reality component to it at the time. There may be something like that in the future, but definitely gamification for that. And I feel like things we talk about vaguely fit here. So I don't know if we have something we in the lab can just put together for this, but maybe. So I'll put that here.
Yeah, that would be good. I think there's definitely something we could do to think about that. Maybe, we did the allostasis machines paper for HCI, like the HCI workshop on emergent. I can't remember what it was called, emergent interaction or something like that. We could do like a version of that for this and get it, maybe something with a little bit more of a dynamical systems flavor. Because the examples we gave in that paper were different. And so, yeah, I think that would be great. So is this linked in the Slack, or is it in the Notion, I guess?
I'll put it in the Notion right now. I'll put it in the Slack as well. Honestly, this particular website is so frustrating to me because I feel like everything important is hidden somewhere. Like, where's the date that we have to submit this by? I don't know.
Oh, I think it just starts in January, and it's like rolling submissions. I mean,
is it?
I think so, because that's usually the way journals work. I mean, they don't...
They're just rolling open stuff?
Yeah, you just send it in, they make a decision. It takes, I guess they say no more than 8 weeks. So, or you get a response, which is always good. So then, you get peer review time no longer than 8 weeks. So it's a pretty quick turnaround. I mean, it doesn't need to be, but it's a lot of journals in the past have taken advantage of the fact that you can spend a lot of time on it and you don't hear back for like a year. And that's not great. So yeah, this is great.
Okay, cool. I will put that call for involvement area. Oh yeah. Just to put, this is also from that same space. I'll share this one. This is last year, but this was I guess phenomenal mind, but phenomenology focused deal, and it had Natalie Dupraz in it. So I didn't see one for this year, but apparently it's all on YouTube, so we can look at it if we want to. But that was in the call for involvement too.
Yeah, that would be good to look into more. Yeah, so that's good. Thanks for that review of things. I think that's about it for the submissions for now. Let's keep on top of this. I know this fall is going to be a lot of writing, so we do need, I think, a process for writing. Because, I mean, we can never facilitate that enough.
I'm sorry.
Oh, go ahead.
And maybe you could just center writing a bit more on our Saturday meetings for a little bit too.
Yeah.
I know we're going to do that in the cognition feature meetings, but yeah.
Yeah, we did experiment once with a drop-in room on Sundays.
Oh yeah, that's right. That was sort of something that happened with Brian before Brian kind of left a bit. I may try that too. Yeah.
Yeah. So I mean, with writing, it's always you have to be flexible. You have to conform people's or you don't want to have to conform to anyone's style. But there are all different types of writing methodologies. There's Pomodoro, which is where you kind of go for a little bit and you take a break and then you come back and you have a set kind of period where you want to write for like, in 10 or 15 minute bursts, and then you take a break and you come back. And that's supposed to keep you from, getting burnt out, or, it keeps you on task. There are other methodologies as well. So, I don't know what works best for people. Sometimes it's just like the fancier methods are just kind of superfluous and people just like to do, like just spend all night writing. But there are advantages and disadvantages to that. So, but let's stay on task with the writing, because you don't want to do it all at the last minute. That's something you don't want to do. So I think both of you, though, are not like new to this. So I think you probably have some habits down. It's just a matter of developing better habits, and I need to do that as well, I guess. I have a... yeah.
I feel like my life is basically just, Oh, okay. Let's talk about that. You posted some stuff.
So I wanted to go over some of the Medium posts that I prepared. And it was 2 weeks ago when we didn't have a meeting. I prepared a couple of posts. So we've been talking this summer about different topical threads throughout the meetings. So this is our Medium, and you can see there are a couple of things here that are new. I've been putting together these discussion threads, which are basically going through the meeting recordings and linking to these different discussions, and then giving some context in the post. So the first one I have, actually I've done 3 on these things. The first one is topics in extended reality. I talked about this last week in the meeting. So this is where we have this graphic. This is a VR system from 1897. It's just a simulation of the environment, of the sensory environment. And so that's what we're dealing with. But we've had a number of discussions on like state of the art in the area. And so this is a collection of links. These are all links to the videos. So that's like at the starting point of that discussion, and it goes on. So I didn't realize we had this many discussions. It went from like May 6th to July 8th, right up to the beginning of NeuroBatch. So I think that's a nice collection. And we have a YouTube channel for the metaverse and spatial computing research videos. So we have a number of experiments that I've been doing with 2 different paradigms, the VR paradigm and the AR paradigm, or augmented reality. And the AR is spatial computing, where you can see your room in front of you, you can map your room, and you have objects that pop up in front of you. Whereas the VR environment is where you're totally immersed in a world, and you can do things there. So we have some videos on that. There's some demos, some how-tos, some talks that have been done in, experimenting with the VR interface. So there are a lot of things that, we kind of put together on that. The second one is on physical computing. So we've been doing the physical computing discussions. Last week I finished up that unit, or that thread, with, I think we had 5 or 6 discussions on this. So this is, the first discussion was on June 24th. That was an hour long. I didn't realize that, but I had gone back to the video and watched it. We talked about a lot of things in that session. We talked about, how the brain is a computer, pan-computationalism, that view, and then, some of the other aspects of pan-computationalism. Actually, that was the second session. The first session was here, where we talked about sort of there's been some philosophical work on physical computing. We talked about the Church-Turing thesis, and then the Church-Turing-Deutsch thesis, which is an extension of that for non-digital computations. Amanda made some good points in the discussion. And, we kind of followed up in the second session then with the pan-computationalism view and some of the things in computational physics and in the world of universal computation that kind of mapped to that. Then we had a third session, which was where we talked about Tommaso Toffoli's paper Action, or the Fungibility of Computation. Misspelled fungibility there. But that was a good paper, and that was basically where they had this I think it was a 5 or 10 speed bicycle that is a computer. So this 10 speeds of a bicycle the gears are basically like a mechanical computer where you're switching between states, and the states are doing something with respect to action. In this case, the human riding a bicycle. So that was a good discussion. This is a thing about these discussion threads, is that they're not just sort of linear in the sense of time, they can also branch off. So, each one of these discussions kind of leads to a bunch of different sub-discussions and, potential things that we can do with them. So, I kind of want to challenge people to think about this as like, where can we go from here? And not just in the general sense, but like what can we contribute to this discussion? I think we can. I just don't know what it is. And I know Amanda talked a little bit about like the stuff on analog computing and how that's interesting, which is, I agree, it's interesting. But I also want to identify areas where we can contribute to this, where our group has like a certain advantage, or, it could be synthetic, like we can bring these areas together where people aren't bringing them together. Or it could be some sort of like specialization that we don't have right now, but we could have very easily. So I'm not really sure what those are. I would like to hear from people. I think there was this really interesting point when I was writing this up. I found that this paper, Tommaso Toffoli's paper on action being an aspect of like computation and information, this is something that links to the work on 4E cognition. And I didn't like make that really concrete here, but that's something that I found interesting. I don't think people were talking about too much. I know a lot of the 4E stuff is very it's not grounded in something that's easy to understand. I don't know how else to put it. But suffice it to say, I think there's something in this area that would be kind of interesting to follow up on. Then we had a fourth session, which was where we talked about Wolfram's notion of universality and like the Rule 30, which he's, I don't know if I have an example of Rule 30 in here, but it's where you have this rule that's applied recursively to a cellular automata, and you can produce this sort of, it looks like the shell of a snail, the Conus textile snail. And so this is a specific snail pattern, a pattern on a snail shell. And we talked about this in DivaWorm. This has kind of been a long-standing thing that we've never been able to get our hands around. But if you look at different seashells, like snail shells and other types of shells, they have patterns on them. When the shell was formed, it has a pattern. And the question is what are these patterns represent? Are they sort of morphogenetic? They're obviously formed in the development of the shell. But what does that represent? Is that a random process, or is that something else? We read a paper once in DivaWorm on how it's controlled by neural processes in the snail. So they have a neural circuit that produces the pattern, but it isn't necessarily like goal-oriented. Rule 30 is actually something, and I found this discussion, I don't know if I have it in here. Oh, it can be, so Rule 30 can produce these patterns that look like they're patterns that are intentional or they're unique to a certain species. But the same rule 30 can be used as a pseudo-random number generator. And that was a discussion. I couldn't find a paper on it, but it was really kind of an interesting point that there's this connection between randomness and some of this pattern generation we talk about. That's really interesting. So yeah, we talk about that, more polycomputation stuff. And then the final session was about, that was last week, where I just kind of went through a bunch of papers that we had left over. So we had physical computation and topology, morphological computation, and RNA computing molecular biology's universal computer. So there was this stuff about category theory and computational topology, which is here. It's basically mapping a category theory map to topology, and then that serves as sort of like a computer. So category theory is where you're working from, different categories of things, and you have these functional connections between them, and you operate on the categories, and that's sort of like a computer. And then you can map that to a topology, so you can see here. And so this is, it's a computer that produces discrete outputs, but also potentially continuous outputs. We also talked about morphological computation, which is this idea. Actually, it's tightly connected to embodiment, and it has to do with they do it a lot. They do this topic is very popular when thinking about robots and biorobotic systems. So when you have a robot body, or you have some body that you think the morphology is playing a role in the cognition, you can use that as a computational device. So we talked about some of the debates in that field. Some people feel that the morphology is really important. Some people feel like it's not. And it's really grown out of this idea, when in robotics, when people build robots, they build a controller. They have a robot, they put it inside of a robot body, and the robot does things in the world. And most roboticists treat the body as sort of superfluous. But in morphological computation, that's not the case. And sometimes, they don't really treat the body as much more than a sort of a random collection of things. But some people have worked on methodologies to sort of incorporate the robot's body into the computation itself. So there's, I didn't see where there was a explicitly sort of 4E framework for robotics in that way. But, it's interesting that they're kind of moving in that direction, but they're not quite there. So it's kind of interesting. And then there's the RNA computing molecular biology's universal computer. And that's where we did this paper on, or this was this talk on, I think it was from Mike Levin's YouTube channel. It was someone, there's a scientist who is not Mike Levin who did a talk on this. And basically they're talking about how universal computation is a missing concept in biology. In biology, we often talk about, say, neurophysiology and plasticity, synaptic plasticity, and otherwise. We talk about neural networks, and then we talk about molecular transduction pathways and gene regulatory networks. But there aren't really any principles to unite those. And so what they're arguing is that universal computation is the way to do that. So that was our physical computing discussion. I think there's a lot to follow up on there. The other one that we were doing kind of in parallel was causality. And so causality is, of course, important in a lot of different areas of science and philosophy and cognitive science especially, and neuroscience. But, we don't, you have to kind of clarify what we mean by causality. And so we did a couple of discussions. We actually did a discussion on causality in circles on May 13th, which that was kind of like causality discussion 0, because it was before I decided to do this series. It was kind of a post inspired by a Johann John post on Mastodon about how how spatialized diagrams are confused with temporal sequences in a feedback loop. So it was this issue of like you have A to B and then B to A, and is that causal or is that just a spatial relationship? So this is like something that we didn't really solve in that session, but we talked about it. We talked about some interesting papers there. And then during the last week in Neuromatch Academy, of course, we talked about causal networks. We talked about how, there are different methods for looking at this: Bayesianism, probabilistic graphical models, methods of integration, time series applications, and more. So we talked about causal models, probabilistic graphical models, and even things like causality for machine learning and scientific models of causality. Then we we also talked in that session, I think, about directed acyclic graphs and then time series based models. We talked about Granger causality a bit, and we talked about that in the last session too, but in this session especially. The third session was a focus on causality specifically as it's treated in neuroscience. So we answered the question, or we tried to answer the question that Conrad Cording asked about why is neuroscience so into causality? And we talked about Nico Tinbergen's 4 questions as a way to sort of get at that. And we covered this in the meeting, but basically the 4 questions concern these sort of proximate mechanisms and then these static versus dynamic mechanisms. So there's a proximate mechanism, there are ultimate mechanisms, there are dynamic mechanisms, and there's static mechanisms. So that's, and this relates to like development, which is proximate and dynamic, evolution, which is ultimate and dynamic, structure, or like phenotypic structure, or trait structure, which is proximate and static, and the adaptive value or function of a trait, which is ultimate and static. So this is, to do with causality, because if you ask, how did something arise? These things, a trait doesn't arise just for one reason. There are a number of causes, so we can look at those things. And so, this just kind of gives a bibliography of that. And so there's also this business about the Bayesian approach, where everyone is really sort of, I think, convinced that that's a good way to go, especially when you read the literature. But it's good for theory building, but it's not necessarily a complete account about what goes on in the cognitive world. So in the cognitive world, when we talk about causality, we're talking about things that aren't Bayesian. And so Bayesian models, while good for theory building, is not necessarily good for the cognitive world. And so then our final session, I think it was the final session, picks up on a point covered in the second session, namely how causality can be inferred from network data. And so actually I prepared this from this discussion, which involved a lot of different papers and approaches. I prepared this, and I think Morgan was the only other person in the meeting, but so there is this sort of model of causality that we kind of came up with, and it's like basically treating the past, present, and future as all these elements of causality. So, the past is, like, in a Bayesian sense, your prior, and the past is often the thing that's going to predict the present. So in causality, one thing happens and then another thing happens. If the present is happening, what caused the present? It's the past. And the past, of course, is like a Bayesian prior. The present is more Markovian, where it's an empirical observation. What I mean by Markovian is that the present doesn't necessarily have a memory. The present can happen just on its own. It doesn't have to have a cause. But if the state that's being generated presently is linked to some prior observation, then there's a causal link there. So we can deal with that with a Bayesian model. But it's also something called a non-anticipatory causal state. So we talked about this. This is something from control theory, which they use a lot in control theory, which is they use these anticipatory versus non-anticipatory states. So if you can predict, the present from the past, it's non-anticipatory, meaning that the system doesn't need to anticipate anything. It's just working from a prior state. Then you have the future, which is something that you need a probabilistic model for. You need to have a model of what's likely to happen in the future. The present can then predict the future, and we won't know until the future whether that's the case, but like we can actually model this using two different types of models. The first is this kind of anti-causal model, and this is something that's explicitly mentioned in one of the papers that we read, or that we went over in that session, or acausal, meaning that it's not causal, it's sort of probabilistic. It's actually anti-causal in the sense that it doesn't make the claim that it's causal, it's just this thing that can happen. And so this is like going from A to B and then B to C. So B is your present state, A is your past state, C is your future state. And then you have this anticipatory approach where you're linking the past to the present and then to the future. In other words, the system anticipates something that will happen. And so it can actually anticipate future states, but it can also anticipate present states from past states. And so this is something that they talk about a lot in control theory, but also Robert Rosen talked about it a lot in his stuff on anticipatory biology. So, that's a nice sort of overview of causality. And so, yeah, I encourage people to look that over more.
I had one question on the diagram that you just had up.
Yeah.
It may be something that's totally not important. When it was going A to B and then B to C,
yeah,
there were two asterisks. One was right to the left of A, and then one was like in the middle. And I don't know if that was just differentiation between them, or
I can't remember. It could have been something to do with like the past and the present. But we actually also talked about like the fact that these can be sort of causal, linearly causal, where you can have like a non-transitivity to them. So you can have like transitivity would be A to B, like B is bigger than A, C is bigger than B, and C is bigger than A, right? Like it's transitive. You can be non-transitive though as well. So if it's non-transitive, it's not causal because there's a loop. So if it's like the A, B, and C are all kind of not related in a transitive way, then it's not causal. And so this is linked to another thing in that session. So that's what the asterisk might be, something like that. But yeah, I mean, like, so this is something, I hope to like revisit these as ways to like kind of drive some research forward or some further ideas.
Yeah, you can look at Amanda's comment because she commented on that. I think it's great that you did this, just to put it together, because some of the stuff I missed myself, and it kind of brings out some conclusions. I even like to just review. I just want to go back and like look at what we just said a few times, because there's a bunch of things there that haven't really fully connected in my mind yet.
Yeah, it's good to go back and recap this stuff. So Amanda said, I don't think I made it to all the physical computing sessions, so I really appreciate the blog post. And then she says, this is definitely relevant for formalizing the concept of resonance, Gibsonian, Fuchsian, especially analog computation. That's true. And then I missed the causality stuff too, so I'll go back to that. I want to read Anticipatory Systems, Rosen. Yeah, it's a good book. Definitely some really interesting things there. And apparently, like, one thing I learned from this is that the control theory literature has this stuff in it, but it's like, control theory-esque, so it's hard to get through the mathematical formalisms and that. But they do, like, they're kind of moving, they've moved in that direction. The question is, can we use that somehow outside of control theory? Yeah. And so so that's and then we have other discussions that we could get into as well. I don't know if people have something they're particularly interested in doing, like a several session thread on that we can put together like that. But that would be maybe this fall we can do one where we kind of visit a topic that we've been talking about in the lab and kind of get at it from different angles. And
I would immediately suggest, and I mean that both like on top of my head and that I haven't figured it out fully. My first discussion, and this also like I haven't manifested this yet into the universe, but these are great pieces for the discussion series stuff I want to do. So like we could have like these would all fit really well. So I don't know if that was intentional or not, but like yes, like these are fun things we could just host a discussion about and do like a recorded thing. However, the first thing that comes to my mind is related to the blog post that I'm writing, which you could say phenomenology, but I think it even more I don't know how to really say it. Something that's a little bit less tied to cognition features, perhaps, and more broadly accessible will be a discussion about the timelines or the time scales and the differences. We've had a lot of different things about. I mean, even like the super sampling things you talked before. The what scale of cognition, but also just what time scale do it could be something in terms of general movement between states and how maybe I don't know if that gets into dynamical systems theory enough, but like broadly speaking, the time scale topic and how that affects cognition, but also maybe some of the theories and methodology about that. I mean, in one sense, you've gotten a little bit into that with the causality thing and the diagram you put together about past, present, and future. And maybe it's like more. I don't know. That's. I don't really refer to that other than time scale, but that immediately jumps out at me as something that I'm going to want to go into.
Yeah. Just taking some notes here. Yeah, I think that's great. I think we should try to follow up in terms of the discussion series and see how that works out, because that would be a good thing to like kind of have people's different takes on.
Yeah, and I'm getting a little bit more literate slowly in like a lot of the adjacent things. So it will be fun to have it like invite. There are certain people that would be really fun to invite into some of the discussions too. I'm not saying it'll be some big formal event, but just like there's some people I know who are like have a lot of expertise in some of these like sub areas, and I'd love to just even if I'm just like email them and say, hey, we're doing blah blah blah, blah, and they give me a response. That would be. There's a lot of things here that are might be interesting. So that's good.
Anything else you want to mention, Amanda, or bring up?
I don't think so. I guess I agree that the general topic of time scales in this context is interesting.
Yeah.
That'd be one thing I'd like to talk about more.
Yeah, it'd be great. Yeah, we should plan something. We never did do the discussion. Like, we've been talking about doing this for a while, and it's hard to put together and get to work successfully. I guess you want to do something that's successful versus not successful. So, well, yeah, we'll keep thinking about that as well.
Well, and one sort of idea about that is one thing I've been considering about that topic is more. Well, it's basically a matter of one aspect is just the timing, is in the sense of would people be okay with like a regularly scheduled discussion session, or would it be more of a well, we want to have it and a kind of an event thing, or would it want it to be like oh well, there's once a month or once a quarter there's a thing, or is it more like once there's a queue of stuff, like once one of these recap blog posts could be made, then we do it, or try to spend the time to do it. I don't really know about that. I don't know. I guess that's been in the back of my mind. I've never really explicitly created a dialogue with the lab about that. So I don't know if there's any immediate feelings. I'm not trying to fish, oh, I want to do this or that. I'm just presenting that as a discussion point about it.
Yeah, I think, the spontaneity part is really important. Just kind of like picking up on different discussions that we've had. And, so it's like, that's good. I mean, it doesn't have to be that spontaneous. So there's a lot of benefit to like preparing things kind of over a while. So like, people give formal PowerPoint presentations on it. They're more polished, but they don't have necessarily the sort of immediate relevance to things. But yeah, I mean, I guess we could just do like, if we really want to discuss a topic, maybe we think about it and maybe we say, oh, I want to do this series, and then, you have to stick with it for several weeks and say, okay, how do and you kind of plan it out beforehand, or you kind of do one session, but the way I've done it is you do one session, you put together some materials, and then you see what was really interesting about that session, and you go to the next topic. So, for example, there was like the general discussion on causality and then the methods, and then, kind of wanted to drill down into some of the disciplines like neuroscience, and then, kind of drilling down to like some of the other methods that kind of connect to neuroscience. So like, it's like, okay, I have these methods for causality. People talk about it all the time, but we don't really talk about what the methods are. And then, okay, well, then what does it look like from the view of, say, neuroscience? And then once you figure that out, then you say, okay, well, what if we kind of drill down even more? What is the sort of the aspect of modeling causality that isn't like the traditional way of modeling it? Maybe moving out to other fields and seeing what they're doing, that sort of thing. So you're kind of letting one session inform the next.
So yeah, that makes a lot of sense to me, and I think in my mind the discussion series, as I'm seeing them, is basically that. Like, yes, do I think a little bit sometimes about like bigger events, like, oh, let's have an event about, I don't know, lab open house, or a orthogonal host a discussion on, I don't know, phenomenology or whatnot. Yes, but I think for the purposes of what we want here is a little more something in between like a conference presentation or hosting an event, but also is like internally, like it can be open, but internally facing, so that we just like cultivates the discussion, or like is a fertilizer in the discussion itself, as opposed to trying to just bring one out of nowhere. As I was, actually, one thing that came right now, and it's a little bit maybe past. I'm just going to share my screen to do this. It's a little bit maybe past the moment, but it's there in the sense of like this old thing from the methods from the spring session here, the post-fix review, which I kind of put that together here. I don't know if this is it. Yeah, between this and then closing out the Fuchs error in general, and kind of I think it'll be a really interesting thing we could have a discussion about, even if it's a brainstorming discussion as opposed like there's discussions that could be. Let me write this out. There can be different kinds of discussions, like it's been really nice to have the book club, which is kind of an ongoing discussion series. The book club is like, here's an external thing. None of us are experts in it necessarily. We talk about it, and it's kind of a, I don't know, that's one kind of thing. But there's also like I would see and actually be interested in, and maybe now is not. Well, I don't know if it's a good time or not right now, but there's sort of this Varela to Fuchs, like there's or even just Varela, but like there could be a discussion about what is like, I like this word, my favorite word, trajectory. Like what is sort of Varela's developmental pathway of his own thing, and how that spilled over into now we have Depraz as putting it forward in a certain way with the cardio microphenomenologies, but also like Fuchs was a little bit different, in the scope and the nature and the way things are talked about, and not. It's kind of it's coming at it from a kind of a different level almost, as opposed to building this sort of ground up thing. Fuchs seems a little bit more like psychiatric and theoretically, what he's getting at in the writings anyway is a particular approach to and kind of like what it like. I would enjoy a brainstorming discussion where we kind of just wrap and sort out what was like the arc, even if it's like the Deprazian arc of the Varela's quest or whatever I'm calling it. That would be interesting to me. And then also the Varela to Fuchs, spending 30 minutes on Varela to Fuchs, both like after reading the book and reading Fuchs's paper, and just what would come from. I mean, Varela, like Varelian lineage, I guess. Like what are those two things? Those are a little bit more deep in the weeds, but those are part of why they're here and noted here is because those are discussions and things that I've I completely forgot about this one where I kind of I pulled some stuff from Fuchs's works that are like some of the big ideas. So just I don't know. Those are things. Those are on the docket too. But this is actually, and maybe this is a segue into my next thing I want to say. But like, I want to queue these things up, and manage them with some task management stuff. But let's maintain our. We were just talking about potential things to do ahead for discussions. So we can go back to that.
Yeah. Well, I mean, I don't know what the ideas are right now. I'd have to kind of think about it. I think the Varela to Fuchs would be very good because it would synthesize a lot of the things that we've been talking about in our discussion group. But I think, the point here is not to like just, I mean, you can like talk about the Varela to Fuchs, but, you want to bring in other things as well. Like, what is it that's, like, where does it fit into the larger scheme of things? Mm-hmm. So it's not just like the two authors, but they fit into like a larger set of issues.
Right. What are the critical, like, these are their lineages are kind of dealing with things. What are the the grand questions and the grand challenges they're stumbling over.
Right. So it's
like
more
concept focused instead of author focused.
Yeah.
Yeah. So like, Varela does a lot of stuff with like, I guess you'd call it complex systems, or complexity. I mean, he's known, you think about complexity, he's one of the, his approach is one of the approaches that people talk about. and so it's like Varela and some of these things. I mean, I know he does this stuff with neurophenomenology, but more generally, they do things with, with some of the other things that his complexity work. And then DePraz, of course, or Fuchs, of course, is doing this stuff with neurophenomenology, but linking it more back to psychiatry. So, like, they're kind of going in different directions in that sense.
Right.
Like, what are the other things kind of around that play a role into it? Aside from, I can't give you like a map right now, but that's what I'm kind of like getting towards, like a concept map or a frontier map sort of approach.
Right, and that's indeed, yeah. Okay, there's a lot here, and I'm happy with that. So we have like 40 minutes left. I imagine you have a bunch of papers you want to talk about, and other things that. Well, how did you want to spend the rest of the time today, Bradley?
Well, I don't know if you or Amanda had anything you wanted to do. I know you might have something you want to talk about, Jesse. You haven't talked about anything in a while. Did you have something that you wanted to?
I have something. I'll let, if Amanda wants to share anything, you can. I have one thing. Okay. There's a few things. This is maybe some of it maybe should have said in the start of thing. I'll just like Jesse. I mentioned this philosophy and history of science project. It's kind of been on hold because I've been last week I had a major family event and also a major I had to mitigate an awful situation that involves vehicles and not being my own fault, but it was such a mess. So between that happening and then someone I wanted to talk to about this specific project with, they're drilling down and finishing a project and not around. So that's been like slightly on standby.
Mm-hmm.
But there's a version of that. I don't know what to say about it. Features we kind of know about, so I'm not going to recap that. There's work to be done there, and I should probably try to talk to Bradley sometime this week about that. This week will be really good for me to. I'm going to have a lot of opportunity to catch up and sink in and be rooted in one spot and do stuff. So I don't know. I would be interested in maybe like a general. If you have some availability at some point this week, Bradley.
Yeah,
I know we have the reading group and Cognition Futures, and I know it's a lot. I know it was really busy, but if there's like a 30-minute time period at some point in the next week that we could just talk about admin stuff, I'll try to do that. Just to give me a deadline to prepare stuff and discuss it with you, get feedback and do it. It can be 2 weeks, but ideally, I don't know, sometime soon.
Yeah.
I don't know if you have any preferences for that, but
yeah, I'll look at my calendar and check back with you.
Let's see. I have things. Amanda, you gave me your new address, which is good. I have things to ship out. I'm gonna see if I can. I'm not gonna wait on the like t-shirts or anything, but I have some to get. Amanda, I happen to have, I think it's unisex or men's fit medium, but I don't think you'd want that as a t-shirt. You would, what would, you don't have to say here if like that's strange. You can tell me in the other chat, but like, everybody tell me their t-shirt sizes again in the ways people want to send that to me. I may be able to get some other things later, but I'm going to send out other stuff sooner. Let me see. I could like commiserate about this task management thing, but I don't. I don't know. I don't want to spend too much time on it. I guess it's just a matter of there's different areas in my life that are very differently the kinds of problem solving in terms of managing the time and managing interfacing with decision making, I guess is the way to put it. I'm going to be, like taking coursework in an established course is its own thing. Like data science is good, probability and statistics or some of the coding stuff. Like those are, I'm kind of familiar with what those. They're new things, but they're I don't know. I forget which is which, but they're a specific kind of devil, like in the Norbert Wiener sense. Like they're not what's being asked in the course and the field of study is challenging, but it's finite in the moves it can make.
Right.
Whereas, certain workplace setting is the scope is like very limited, but the problems have a different kind of complexity because they're dealing with people and the people changes. And then you have things like what I tried to say last time about the nature of the theory and the language that I'm dealing with. Like when I'm doing like the real, I don't know what to call it. Maybe this is something I'd ask you to. What's a good word for when I think of research, I think mostly research is you kind of have a hypothesis or an idea or a theory or something, and you're trying to collect data to put it back and forth, like in a very scientific, maybe empirical, maybe hard science, quantitative research that you're accumulating data and you're processing it and you're getting the results. But what's the word for like at the level of the ideas, you're trying to develop the theory. I know there's theory building, and you're developing a theory, and then you're sort of ironing it out as you get to a place where you can test it, or like you're kind of in the forge of the idea theory forge, trying to combine and synthesize or break apart and reform at the theory level before the testing. Is that what is that called? I don't really know. But I guess what I'm saying is that managing I know as I said many times and I keep saying it to myself, my future basically lies in having these time blocks of focus. That's I know if they happen, then I move forward, and if they don't, I stand still. It's very simple for me. That's how I work. And I'm just noticing what happens in those time blocks. It's kind of the same, but there's also like the nature of sorting out what to do in them seems to radically vary along these lines in terms of the theory. Like how much am I developing a theory in one spot, or trying to like sort out the discrepancies between the theories and add something here or there, versus when all that's pretty fixed. And I'm just, that's on my mind a lot this week.
Yeah. I don't know what it's called. It seems like there's a term, but I don't know what it is. So you're saying...
I basically just use the word theory work. And I know there's like theory building is a thing, but to me that's the theory work. There's got to be a better word for it. But.
So I guess like when you accumulate data and you do an analysis, that's kind of like... I mean, the terminology is not... I'm not crazy about it, but it's basically, you might do like... an experiment and an analysis, and then you kind of put together like a data set. So you're kind of collecting the data. I don't even know if there's a good term for that, actually. But it's like, with theory, it's like you're building the theory, you're kind of putting together things. And then so I guess it's not really synthesizing. It's maybe like, I don't know, epistemic building, or I'm trying to give it a fancy name. Epistemic building, or maybe like synthesis or construction. It's definitely there's a terminology to be worked out there. Yeah.
Yeah.
So
and it's I guess I'm personally exploring. Is there a kind of like, it's kind of like at a macro level, how different people handle it differently. But sometimes the movement between, I guess I'll just say it in very simple terms, fixed theory problem solving. When things are fixed and you kind of easily grasp the nature of what the theoretical boundaries are, there's a different speed and a pace. It's kind of like a road that's well paved, perhaps. You can drive fast on it and not worry about it. And these are very loose analogies. But then the thing that's not really well paved, you have to be very... The optimal speed is very different. The speed at which you can cause injury or harm or damage or just waste time, or whatever, is different.
Yeah, I see what you mean. It's just basically that you have to sort of, they use this term map and territory. Mm-hmm. And like, in this case, your map isn't even very good. It's just kind of like you have to make the map, and you have to explore the territory more before you can even get to the map or something like that.
Yeah, and I feel like, in terms of just like general time management, I guess another like part of this discussion is some of the things, like some of the far ends of the theory work where I'm like, yeah, the whole, like, this whole arena is something I'm now like putting into the question zone. Like I'm willing to say, I don't like all of this stuff, and you kind of have to say, okay, well, what are the limits of that? Because you need to like some of the books that I've gotten. I think I continue to understand at a different layer the Tony Shamaro's opening lines of his Embodied Cognition book, saying, "Oh, I love Jerry Fodor. He's a great scientist, and I really admire and respect him. And I disagree with everything he said." And what that really means is, like, I feel like I'm in this space of, I've got books on my bookshelf right now that are things I don't agree with, but I feel like I have to kind of, it's this weird line between doing like scholarly due diligence to know stuff versus not trying to totally, you don't have to understand all the positions you disagree with in the past, like finding, like, and this is the thing that actually kind of, to make it more modern, like the amount of just trash books that are being put on Amazon that are just generated. We talked about that when I was here last time, like the junk, junk generation, the generatively GTP3 created, textbooks that are just don't make any sense about anything and just, oh, what's a book? And it has sentences that are complete. Like it's that tension between what do you do with your limited attention, like your ability to focus or whatever, versus I don't know. Like sometimes it feels like sometimes you have the sports car that you can go fast on the road and just get a bunch of stuff done. Sometimes you're in like the off-roading SUV Jeep thing that isn't going to go fast, but you can do a lot of really great navigation off of problematic terrain. And I feel like I'm just trying to figure out how to best, because I have to drive both cars. Basically, I can't stay in one. I don't really want to stay in one, but I have to. Is it a thing? I don't know yet, but on my mind is like, is it a thing where I can just, okay, I've spent one Pomodoro in the sports car, now I can jump over to the Jeep, or is it no? I need a 4-hour block of multiple things in the Jeep space before I can go to the sports car. Again, very, very loose analogies, but like from the standpoint of doing the work on these different arenas, that's on my mind. So that's my I don't know, not Reader's Digest, but like my column. I feel like I have a column on the personal experiences of dealing with administration or time management or whatever it is.
Yeah.
So there you go.
Yeah, again, like I want to revisit this business about like theory building and, kind of like the analogies to like data analysis and things like that. So, yeah.
It has been good to find, like, I don't have it here with me and I kind of regret that I didn't bring me to where I am now, but it's really, I think it's, and this is to go back to the philosophy and history of science. Maybe what I should call this actually is the theory building project, or something like that. Because what I really want to understand is how people constructed the theories and how has that changed. Always trajectory stuff, yeah. But like not just, I don't like history is nice of like what happened, but like I want to know why and how the theory developed. So I guess that's basically more philosophy of science. But I feel like I would love to come up with a proper description for this, and I know I have a couple people interested in it, and I just have to figure out what to do with it. But it keeps going back to that, and I know like that's something that we've always come back to in Aurel here in this lab is this topic, and I'm really fortunate for that. But that's still percolating in the background. There's obviously a bunch of other things more immediate than it, but I want to do something with it. So I'll leave it at that for now.
Yeah, I think that sounds good. I think that's nice that's being developed. And it takes a lot of, thinking and rethinking and rescoping. So yeah, I think that's good. I think there's a lot under theory building that we can do that's really, people don't really have a lot of resources on this. This is something, if you go and you'll find things that are either sort of specific to a certain field or very old or very general, and I think there's a lot here that can be contributed to, and there's a lot that people don't really think about too much. There's a lot of stuff on data science, but not a lot on sort of, if you were to like have a theoretical analog or even a way to interpret data at a deeper level in a data science context. Those resources don't exist. So, I think there's a lot of space for that.
There was also, there was one thing, I'm just going to note. Excuse me. I can't find it right now, but note to myself. There's some philosophy journal or something that was asking for shorter submissions, and it was, I think, related to this somewhere, and I have to find where it is. I just got access to a bunch of things along those lines, but I'll look into that. But that's it. That's all for now. Yeah.
All right. Well, that's good. Well, yeah, we can come back to this later. So last week, Morgan was here, and he talked about, or we talked about this stuff on computational psychiatry. So in our Slack, again, we have this computational psychiatry channel, and Morgan is consistently updating it with readings. And, if you want to get a handle on what it's about, this is a good place to go. Now, Morgan has his own take on it, and it's more inclusive than what a lot of other people will say that field is. So he's got a lot of things in here, range spanning from brain imaging, behavioral genetics, disease states, connectomics, neuroanatomy, other types of technological things, computational bioengineering. So it's a really broad approach to things. So I definitely would like to follow up with that. I don't know if Morgan at some point he said he might give a talk on it, or at least go through some resources. So we'll see. So I'm just pointing that out so that people can engage with that. Hussein, I think was here briefly, but had to leave, brought this piece of software to my attention yesterday. And this is an open source platform that you can use to design and prototype in a spatial canvas. And so this is useful for spatial computing applications, building three-dimensional objects. So this is a program called Bezel, and they have a community, they have docs, and made with Bezel, so you can make all sorts of different augmented reality objects. So this is the dynamic island, room cards. This is Pokemon figures, floating apple, mystery portals, things like that. So there are all sorts of things you can make with this. It's kind of like what we might use Unity for virtual objects that are in a kind of a virtual space, but it's something that's specialized for this sort of spatial computing paradigm where you have augmented reality objects and then you map them in space. So thank you for that, Hussein. Hussein's doing very well. He's wanting to contribute to the lab in terms of some of our open source and virtual worlds XR activities. So I hope to see him around in the next few months. He might give some reports to the group here on what he's doing. The other thing I wanted to mention is that this past week, the Active Inference Institute put on a symposium. This was a live stream on YouTube, so the videos are still available. This is like 11 hours of content, but I think it was on Tuesday and Wednesday, if I'm not mistaken. But they basically had a series of talks. So this is the YouTube channel, Enacting Ecosystems of Shared Intelligence. That was the symposium name. So this was, an action, and some, actually it went from philosophy to some of the other topics that, even software and other things. So if I go to I think I have the image here. This is this is interval 1. This is I don't know if I can make this bigger, but basically this is the schedule for interval 1. So there was a talk on doing recordings in non-human primates, suggesting that predictive coding is implemented through predictive routing. That was Andre Bastos. Keith Duggar gave a talk on active inference in the actor model. Sanjeev Namjoshi gave a talk on next-gen active inference tools. So this was on like doing this sort of thing in software. And there were some educational resources as well. Inés Hipólito gave a talk on resurrecting Gaia, harnessing the free energy principle to preserve life as we know it. Eswin Paul gave a talk on the PYMDP toolbox and doing sophisticated inference techniques. Takuya Isamura gave a talk on canonical neural networks for shared intelligence and active inference modeling approach. Shanna Dobson gave a talk on dark imaginarium, shared intelligence as an infinity curiosity type. And then, yeah, so we had a bunch of different talks that were, I didn't get to attend all of it. I looked at the first session. I didn't really look over the second session as much. But the program is here in Coda. You have to log into this, so I don't know if you'll have access to this, but it's a good, it was a good session. You can look them over on YouTube. Let's see. This is a talk, or this is a session that's coming up. This is in December at NeuroSim. So there's this session. So they're doing so this is from, I think, LinkedIn. This is something that Morgan sent me. For those at NeuroSim this year, I invite you to come see my talk on why deep learning works. It will be either on December 15th or 16th as part of the conference in our special workshop on dynamical systems, edge of stability, and heavy tails of machine learning. So this is a workshop that's going on as part of NeuroSim. It sounds interesting. Like some of the topics that we talk about a lot. I don't know if this will be made available on YouTube later, but we'll see. In this invited talk, I will discuss the latest results of the Weight Watcher project in HTSR theory, which I'm not familiar with. And most importantly, I will address some of the fundamental questions around AI models, including why deep models are actually deep. That is, why does a model with 10 layers outperform a big model with 3 layers? And we've talked about some of the reasons why that is in the past. I mean, there's this idea that as you increase the number of layers, you increase the specificity of processing, but he's going to get into some of this. How is it models can generalize without memorizing or overfitting to their training data? So how do you generalize without overfitting? How to solve the outstanding problem of setting the layer learning rate during training to accelerate convergence. So this is a technical problem. I'm not familiar with it really. And how we can detect signatures of the emergence of AGI in very large language models. So this is, again, this emergence thing. I don't know, that seems pretty speculative. But anyways, that's an interesting thing that people are maybe interested in following up on. I think that's all I wanted to talk about in terms of the updates. Okay, so I'm going to spend the last 30 minutes talking about these readings. So this is a set of readings on neurophysiology and energetics with respect to cognition. And so the first paper is from the Journal of Neurophysiology. And this is Yuri Arshavsky, who's at the Biocircuits Institute. And this paper is Brain Energetics and the Connectionist Concept in Cognitive Neuroscience. So this is a thing that I've kind of been interested in. I think I talked, I had a feature in the DivaWorm meeting, it was a while back, on they were looking at C. elegans development and the energetics of it. So energetics is an interesting field. It's basically the idea that there's like an energy balance, and it's very much related to homeostasis. And, you can talk about energy balance, and there's kind of you can talk about it in a way that's sort of mystical, and then you can talk about it in a way that's sort of grounded in, like, sort of a biological accounting. In other words, like, you can measure energetics in different ways. And so in the C. elegans embryo, they can actually measure different parameters that relate to energetic flows and things like that. So, you have energy transfer. I think we've talked about entropy in some of our meetings, or maybe some of our cognition futures meetings, where you have a closed system where you put energy in and then you let the system run, and then eventually you run out of energy. It becomes bond energy or entropic, and so you run out of energy, and so things run down to sort of either a mean state or a minimal state. So in this case, though, this is an open system. This is where you have energetics, you have energetic balances, you have fluxes, and but it's also related to homeostasis, in that the system has to maintain a certain level of energetic stimulation or energetic balance. And so that's what they're kind of getting at. And he's linking this to the connectionist concept. So this, of course, is the more traditional cognitive science aspect of connectionism, which is where you're looking at different networks and complex interactions among neurons. So one of the central paradigms of modern neuroscience is the connectionist concept, suggesting that the brain's cognitive functions are carried out at the level of neural networks through complex interactions among neurons. This concept considers neurons as simple network elements, whose function is limited to generating electrical potentials and transmitting signals to other neurons. So if we think about like a connectionist model, we think about the circles and the connections between the circles. And, we don't really, sometimes you don't even consider electrical potentials in a lot of connectionist models, but they just use weights to summarize that. But of course, you can put more biologically plausible aspects into these models, like, different ion channel fluxes and things like that, and they transmit signals, meaning that there's a connection between one neuron and another. So that's connectionism. And so, there is a sort of an energetic aspect to that, as it is. So what he's doing is he's focusing more on that energetic aspect. So here I focus on the neuroenergetic aspect of cognitive functions and argue that many findings from this field challenge the concept that cognitive functions are performed exclusively at the level of neural circuits. So this means that cognitive functions maybe don't just happen in neural circuits, that they're maybe larger than that they involve energy flux and energy balance. Two of these findings are particularly foretelling. First, activation of the cerebral cortex in humans, where sensory stimulation or solving cognitive problems is not associated with a significant increase in energy demand. There are different ways to measure this. There's a type of glucose imaging that they do in developmental contexts, but this is a way to look at the amount of energy being used in. I can't remember the details, but this is one of the techniques they use. But you can also use other kinds of techniques. But this is interesting that activation of the cerebral cortex is not associated with a significant increase in energy demand. There's this, I've seen in cases where people talk about the connection between artificial neural networks, or ANNs, and biological neural networks, or BNNs. And we wrote a preprint on this. I wrote this with Krishna Katyal, where we talk about the energy demands of a board, and a computer, and then the brain. And so the brain is actually doing this kind of work at a much lower energy level than a computer. So if you had a computer that's processing a certain amount of data and doing this sort of what you might say is cerebral cortex analogous work, it's using a lot more energy. So, and there's a reason for this, is because if we did use that much energy, we would always be searching for food. We probably wouldn't have enough food to survive. So the brain does use a lot of energy relative to the rest of the body, but it doesn't really require a significant increase in energy demand. Second, the energetic cost of the brain per unit mass in primates, including Homo sapiens, is approximately proportional to the number of cerebral neurons, but not to the number of synapses. So this is where, the energetic cost is of sort of maintaining the neuron, maintaining the metabolism of the neuron, and it's not related to the number of synapses, the complexity of neural networks, or the level of the brain's intellectual abilities. These findings contradict the predictions of the connectionist concept. So, connectionist concept suggests that there's a lot of work being done in the sort of the putting together of connections, basically, or that the connections are the thing that drive cognition. And you might say, well, there's where the energy expenditure is. But that's actually not the case. Rather, they suggest that cognitive functions are generated by intraneuronal mechanisms that do not require much energy. In this context, interactions among neurons would serve to coordinate activities of neurons performing elementary cognitive functions. So this is interactions among neurons would serve to coordinate activity of neurons performing elementary cognitive functions. So these interactions are where the cognitive functions are really happening. The function of the network mechanisms also do not require much energy. I hear a couple of comments. I see Morgan's here. Hello, Morgan. Okay, so yeah, Amanda said, well, Jesse gave a thumbs up, I guess. And then Amanda said, this is awesome. I'm very interested in the connection between metabolism, bioenergetics, and brain activity. Oh, that's great. Haven't seen connectionism brought in before. Yeah. And then Jesse says, same. You see San Diego. Oh, the author's from UC. Well, yeah. I can follow up with the author if anyone has questions. Okay. Yeah, so this is an interesting area. I don't know if he doesn't really have any diagrams, but this is basically the energy consumption for neurons in the cerebral cortex. This is the resting state, which has is problematic in a number of ways, because the resting state represents activity. It's just not activity that's necessarily guided towards any specific thing. So, but regardless of that, that's a good, I guess, baseline. Synaptic transmission includes the activation of postsynaptic receptors, presynaptic calcium entry, and glutamate recycling. Housekeeping includes energy use for processes having no relation to network functions of neurons, such as turnover of different molecules and transport mechanisms and other things. So this is the graph, and you can see that synaptic transmission takes up maybe about 40% of energy consumption. This is like the firing of action potentials, basically. Or actually, that's in a different category. So synaptic transmission is actually the transmission of things in synapses. That's like the neurophysiology. The generating action potentials part is here, and that takes up about 20, maybe 15 to 20% of energy consumption. This is where the action potential is actually generated. And then there's housekeeping, which of course is in the cell. You have housekeeping maintenance functions. And then there's maybe about 10% or 15% where there's maintaining resting potential. So this is the balance of sort of, you have the resting potential of the cell, you have the generation of action potentials, and then the repolarization of the cell. So this is interesting that there's this huge area that's devoted to synaptic transmission. And so it's this definition that I gave before. So there's a lot of housekeeping within the synapse, I guess. So these categories are kind of, maybe overlapping in some ways. But anyways, so I guess the argument here is that, if you look across studies, and this, I guess, is sort of a meta-analysis, that this really challenges the pure connectionist concept, this idea of having a pure connectionist network that's just about information transfer. That's not really the way the brain works. It really depends on, energy consumption and metabolism. So compared with other organs, the mammalian brain is energetically expensive. And of course, it's one of the reasons why big brains are rare, but also that, when we have, like when we undergo starvation, or especially in development, when you undergo starvation, there's a sort of a priority of energy conservation. So, there's sometimes the brain shuts down in order to protect the rest of the body or provide energy to the rest of the body. And in some order, of course, big brains require a lot of energy. So when big brains evolve, there's a sort of a reprioritization of energetic distribution in the body of the organism. So, there has to be a corresponding change in diet, a corresponding change in behaviors, and so forth. Specific metabolic rate per unit mass is higher only in the heart and kidneys, whereas the specific metabolic rate in other tissues is lower. So this is in terms of the mammalian, organs, looking at the mammalian brain compared to other organs. So this is where, the metabolic rate is higher in the heart and kidneys, the rate in other tissues is lower. The local metabolic rate within the brain is higher in gray matter, the cerebral cortex, than in white matter, or the corpus callosum. So the gray matter is where the metabolic rate is higher, the white matter is where it's lower. The main source of brain energy is glucose in the cerebral cortex at resting state. Approximately 90% of the glucose is oxidatively metabolized to CO2 and H2O, so carbon dioxide and water. About 80% of the produced energy is consumed by neurons, whereas the rest is used by the glia. So as far as the neurons are concerned, about 50% of the energy they spend is devoted to synaptic transmission, which we saw in the figure. The largest part of this energy consumption supports the transmission of signals from glutamatergic synapses to pyramidal cells, which play a critical role in performing cognitive functions. So this is where, we have these, in a connectionist model, we have this transmission of information from one unit to another. And that's really belying like what's happening in the brain, where you have this transmission that maybe, different types of neurotransmitter require more energy, or more energy is devoted to those kinds of cells transmitting to other types of cells. And so there's this differentiation in the sort of the topology of the connections network that is really based on energy. The rest of the energy is spent on generating action potentials, maintaining resting potentials, and housekeeping. So, there's a lot of literature on sort of the primate brain and the scaling of the brain with respect to different brain sizes. So, in primates, for example, the frontal cortex is the thing that expands the most. And that's where you get the most new neurons that are, if you have a bigger brain primate, where those neurons expand in terms of number. And so there's a certain amount of energy devoted to that. And so that changes the primate's ability, the need for more food, the need for sort of a reprioritization of energy homeostasis in that organism. So Herculano Hosel, who has written a lot of things on brain evolution and in primates, wrote in a review on the evolution of the primate brain and cognitive abilities. This is a quote. Since neurons interact combinatorially through the synapses, they establish with one another, and further so as they interact in networks. the increase in cognitive abilities afforded by increasing the number of neurons in the brain can be expected to increase exponentially with absolute number of neurons. In other words, so neurons are interacting combinatorially through synapses. So if you have, 100 neurons, you have many, many more ways that they can interact. And so they interact in networks. The increase in cognitive abilities afforded by increasing the number of neurons in the brain can be expected to increase exponentially with the absolute number of neurons. So that means that the number of cells or neurons isn't really the thing that's scaling with intelligence. It's actually the connections, and therefore the energy consumption is in those connections. The brain's evolution leads not only to an increase in the number of cerebral neurons and interneural connections, but also to higher complexity of the structure of dendrites and synapses. And so human pyramidal neurons have more complex dendritic arbors and a greater number of dendritic spines of larger size compared with other primates. So you can do this energy budgeting here. This is for different species. These are human and non-human primates, and then there's the mouse and the rat. So they have measurements for the whole brain and for cerebral cortex specifically. So you can take just the cerebral cortex or the entire brain. And this is these values are cerebral specific metabolic rates of glucose. So there's a way to measure that, micromole per gram per minute. So this is the numbers here. You can see that there's this. I guess it's actually falling here. I mean, looks like there is more there's a higher metabolic rate in mouse and rat for some reason than in primates for the whole brain. And then in cerebral cortex, you see it's higher as well. I don't know why those numbers are the way they are. Perhaps they talk about that in the table, or when they mention the table in the text. I'm not seeing it. Okay, so they actually talk about this a little bit in the paper. Therefore, one can expect that the specific rate of metabolism should be the highest in these areas, which are the areas that are the prefrontal cortex and temporal lobe that are most important for performing cognitive functions. Okay, so this didn't really confirm this expectation. A study of the local specific rates of metabolism in the human cerebral cortex showed that regional homogeneity of these measures were the case. Variations of these measures across different areas within 5%. For example, the prefrontal cortex demonstrated average values of these measurements, whereas the primary visual cortex that is not at the hierarchical top of the processing hierarchy had the highest specific rate of metabolism. So this means, I guess, I don't know what that means. But that's, there's a lot in here about like metabolism, and they have some interesting measurements here. And then the other thing is that metabolic rate during rest and activity is another thing that contradicts the pure connectionist concept, which is obtained in experiments. So they're comparing the human cerebral cortex in a relatively passive state where subjects are in a sort of resting state and in an active state. It has been shown that activation of the cerebral cortex is accompanied by a rather small additional energy requirement. So activation of the cerebral cortex doesn't require this a lot of additional energy. Maybe that's what's going on here in these measurements, where the whole brain and the cerebral cortex seem to be consuming less glucose than in the mouse and rat. But I don't know. So in this respect, the brain is radically different from the muscles, whose activation increases energy requirements tenfold. So if you're activating a lot of muscle, there's a lot of energy required for that. But the brain does not require that much energy. Whereas the muscles are producing force, they're producing muscle power. whereas the brain is doing something else. And so they go through this. So I'm not going to go through the whole paper. I'm going to, if you're interested, I can provide it in the Slack. I think this is a really interesting paper from the perspective of thinking about connectionism, thinking about brain energetics, and thinking about biological neural networks versus artificial neural networks. The other paper here is about predictive processing in particular. And the title of this is in the Annals of the New York Academy of Sciences. And this paper is called Evaluating the Neurophysiological Evidence for Predictive Processing as a Model of Perception. So this paper has a number of authors, including Andy Clark, who's, of course, a philosopher of mind. So this is neurophysiological evidence for predictive processing. So this is not artificial neural networks, but this is like looking at one of these theories of processing and what the evidence is for it, and especially the neurophysiological evidence. So for many years, the dominant theoretical framework guiding research into the neural origins of perceptual experience has been provided by hierarchical feed-forward models. So these are kind of, they're not artificial neural networks, they're not connectionist, but they are these theoretical models of what's going on in the brain. So this is just perceptual experience in general, in which sensory inputs are passed through a series of increasingly complex feature detectors. So like, for example, in vision, you'll have, like, you're feeding a visual signal into a number of feature detectors. First you're trying to detect blobs, then you're trying to predict shapes and edges, and then finally, whole objects and things like that. So this is the kind of theory that, where you have these feature detectors and you end up with this, these scenes, these visual scenes that you can predict especially over time. And this is like the standard in cognitive science where, if you're wanting to sort of build a model of cognition, it's usually about like some sort of sensory input being processed in different ways. And so there's information in the sensory inputs, the visual inputs, and you're trying to extract that information. However, the long-standing orthodoxy of these accounts has recently been challenged by a radically different set of theories that contend that perception arises from a purely inferential process, supported by two distinct classes of neurons. The first of those is those that transmit predictions about sensory states. So these neurons are predicting sensory states. You have a sensory state that, maybe it observes a couple of sensory states and it knows kind of what that state should be. And then the second is those that signal sensory information that deviates from those predictions. So these are kind of like error correcting or error generating neurons. So they're kind of observing the sensory states. There's one set of neurons that can maybe make a prediction as to what state it belongs into, so it's a classifier, and another set of neurons that signal if there's a deviation from that or error, if there's an error being generated. So you can think of it maybe as like a categorizer and like an errorizer, I guess. And then this is, of course, how predictive processing works. But this is, of course, not necessarily rooted in neurophysiology. This is just, again, another theoretical construct of how this works. Although these predictive processing models, or PP models, have become increasingly influential in cognitive neuroscience, they are also criticized for lacking the empirical support to justify their status. So this is largely like, the idea that in PP models, there's feedback instead of the feed-forward model of this sort of hierarchical feed-forward model thing. So, this again is just kind of like a theoretical model. It's not really, something that we've tested a lot. This limited evidence base partly reflects the considerable methodological challenges that are presented when trying to test the unique predictions of these models. However, A confluence of technological and theoretical advances has prompted a recent surge in human and non-human neurophysiological research seeking to fill this empirical gap. Here we'll review this new research and evaluate the degree to which its findings support the key claims of predictive processing. Okay, so I guess Amanda had to leave. Okay, great. And I'll send the PDFs out. Okay. And so just finishing up on this paper. So yeah, this talks about predictive processing and the potential evidence of this. And so this is a typical predictive this is a simplified hierarchical predictive processing model. This is based on a circuit proposed by Rao and Ballard, and this is the original citation for predictive processing. So in this case, each level is composed of a population of reciprocally connected expectation units. You have an expectation unit here, which is the thing that's making the predictions about category. And then the error unit, or the red neuron, that's making the predictions about the error. So you can see they're reciprocally connected. You make a state, you predict a state, you find out the error, and it's kind of like a mean and standard deviation. So you find the mean of what it is and then the standard deviation. Or you find the category and the error rate. And so then you have these different levels that are connected together. They're connected. So you have a chain of these that connect maybe over time. And that's how you basically can figure out something over. So you can have continuous cognition and you can have this predictive processing happening. So this is basically, PP claims that this process is neurophysiologically instantiated in an inferential hierarchy composed of two functionally distinct neural subpopulations. So this is neurophysiologically inspired, but it doesn't necessarily link us back to the energetics, which is kind of why I picked these two papers, because I wanted to talk about the energetics of the brain, and then I wanted to talk about some of these theoretical models that say that particular neurons are doing something in cognition. And so, given the last paper, we know that energetics doesn't really cost a lot, or cognition isn't costly necessarily at the neuronal level. It's costly at the connections level. And so this is a kind of an interesting thing, and I'm not going to put it together any more than that. I'm just going to leave it up to you to think about for later. So, PP is, PP proposes that its error units signal only unpredicted object identities. In other words, PP hinges on an inversion of classical feedforward accounts, whereby it is the descending signals that provide representations of the external world, while forward signals provide the feedback, and this modifies these representations. So again, you have this feedback mechanism that's doing a lot of work. Thus, PP has at its core a process of predicting the present, in which top-down flows attempt to match the incoming sensory stimulations. But they achieve this goal using information that spans many windows of space and time. So, you have these sort of neurons, but the connectivity is the most important part of this. And so to date, neurophysiological investigations of predictive processing have largely centered around testing four key hypotheses. The first is error signaling neural responses to sensory stimuli, and this should scale inversely with expectation. The second is top-down signals represent sensory prediction. The third is at each level of the cortical hierarchy, there are two functionally distinct neural subpopulations, representing predictions and prediction errors. And then 4 is prediction error minimization, is achieved through reciprocal exchange of error and prediction signals across levels, a process known as hierarchical inference. So we're doing this inference across different levels or time points, and there's a lot of complexity as to how these can be implemented in the brain. So there's a very clear example of this in the cerebellum. Not quite, the cells are more specialized than this, but you do have this sort of prediction of error in terms of movement, in terms of language, and things like that. So I think that's about all for this paper. I'm going to and also post this in the Slack. And so I hope you found that interesting. So any comments or questions on that?
Both good papers. I want to look at them. The first one in particular is the metabolism aspect of it, and that it's a physical situation that's dealing with, like, it's really hitting some embodiment stuff, and the disparities that it pointed out, I think are really interesting. And I haven't dived into metabolism in a while, but seeing that paper reminded me, like, oh, like, yeah, neuroenergetics is probably something that I'm actually really interested in, and I never really put it. It's something that I didn't really put together or know was a thing. So, and particularly juxtaposing it to like connectionism is a really interesting thing. So I think I'm going to try to. That's definitely a paper of interest for me. And then also, another one too, but that one was kind of a surprise, both in terms of the content and then in terms of, oh yeah, like, that's not been on my mind at all recently. So yeah, that's good.
Great. Morgan, did you have anything to say? Any comments?
Okay.
All right. Yeah. So yeah, I think there's a lot. Oh, go ahead.
No, sorry, I'm going to cough. But no, that's good. I'm gonna head out myself. But let me know if you have the time to meet about some stuff later this week. I'm gonna kind of be, as the saying goes, battening down the hatches in preparation for the end of the year.
Yeah.
My goal.
All right. So thank you. Talk to you next week.
All right. Take care, everybody.
Take
Bye.
care. Bye.